Eight's nominated.
We're about to find out. So, and we can go over any while we're in the setting that you want. I don't mind at all, but this is all from assignment number 12. And we're going to start with problem 8 because we're not sure what it is. So I'm going to jump right in and make the table. So remember that for your table, it's just a pretty simple, straightforward thing. So for number 8, what numbers am I going to put down the left-hand side?
The ones on the x-axis.
-3, -1. Yeah. And then down the right-hand side.
7, 3, -3, -5.
Gorgeous. Yeah. And did I ever bring this up in your class yesterday?
Yeah.
We talked about delta y, delta x, right? So we know what that means, change in y, change in x. And so what we're going to do is we're going to just approach this. And there's 2 of these on the district assessment too. So I'm going to cap them off like this, just so we're all clear on what we're working with here. What's my delta y for this pair here? -4. So we're going to put -4 for the top of our rate of change fraction. Okay. The y dropped from 7 to 3. That's a -4. What is our delta x over on the left-hand side? +2, right? If it gets bigger, then we put a positive number. And what is -4 over 2 reduced to?
-2.
-2. And you could put -2 over 1, or you could just go all the way down to -2. But what we're looking for now is in the other pairs, we want to see if that slope or that rate of change remains constant. So we're going to go now to the yellow bracketed pair. And just look where I'm kind of moving my pen right now if you're confused. That's what delta y looks like, is how does 3 become -3? How does 3 become -3? You subtract 6. So we put a -6 on the top of our fraction. And then we move to the other side of the table wall over here. How does -1 become 2? You have to add 3. Right? -1, you have to add 3 to get it to go up to +2. And what does that fraction reduce down to?
3 or -3.
-2. Okay.
-2.
You're fine. You're fine. It happens. Sometimes it starts to snowball. So just take a deep breath. And then we're going to check. So far what we have are 3 points that are definitively in a straight line. But like I showed you, I think at the beginning of class yesterday, you can have 3 points that go in a straight line like this. And then you assume everything's fine. And then suddenly the 4th point is over here. And you're like, whoa, 4th guy, what's up there? So that's why we have to finish the job. What's up, brother?
Isn't that called an outlier?
Yeah, I mean, it can be. That term applies to a lot of things, but you could call it that. I mean, yeah, we tend to use that word more when we're talking about
Data.
like data sets, like scatter plots and things like. But no, you're not wrong. Like in the normal context of the word, I wouldn't have any issue with that. It doesn't fit in with the rest. I think that's a good word. And then let's do this bottom pair. And again, when I use these terms, just understand, I'm just asking you simple arithmetic questions. Delta y, how does -3 become -5? You go down by 2. Very good. And then on the left-hand side of the table wall, how does 2 become 3? You add 1. And what does that reduce to? And you should now see that all of these fractions, all of our rates have changed. They may not have looked the same at the beginning. They were all born from different numbers, but at the end of the day, they all came down to a rate of change of -2.
So they're linear.
So number 8 is linear data. Yes. Are there any others that you'd like to go over? I mean, honestly, every problem is we do it exactly the same, but I'm more than happy to help you.
Can you do number 5?
We can do number 5, sure. So for number 5, again, I'll just jump right in and make the table. So we have this XY table. And down the left-hand side, we're going to put all of our XY guys. And I think this is a counter. No, it's not. 4, 5, 7, 10. And then down the right-hand side, we're going to put 2, 5, 10, 20. Remember that you can find the no pretty quick, right? You'll never find it on the first one. This first one is just laying the groundwork. This is a baseline. So with my red brackets up there, what's my delta y? +3, right? It's a +3. And what's my delta x? How does 4 become 5? plus 1 or positive 1. That's just a nice simple reduced rate to 3. So that's just the baseline. What we're going to do now is compare everybody else. And again, if we hit one right away that's a discrepancy, we're done. Like there's no need to do them all. And you're going to see it really quick here. How does 5 become 10?
You add 5.
You add 5. Like this one's got no shot. Let's just make it official. How does 5 become 7?
That too.
Yeah, and 5 halves does not reduce to 3. Therefore, we can stop right here and say nonlinear. Okay, we've already shown that we have 3 points right away that do something like this. Boom, boom, boom. Right? If the first 3 aren't in a line, then all 4 of them sure aren't going to be, right? Anything else on this topic? Okay, I'm going to teach you something real quick. And I don't even know if you need to write this down, but I do need you not looking at your Chromebooks for about 5 minutes. So yeah, you can close them or you can just have good willpower. But there's a section on your test. It's on the district assessment today where I'm going to give you equations and ask you if they form a linear relationship, or what I'm trying to say is like, is it a linear function? Is it a linear equation? Have you guys ever seen this before?
Yes.
If you're the only people that might say no would be an 8th grader. Do I have any 8th graders in this particular section? Have you seen this before, you guys? Okay, so what this is we're going to still worry. You're going to see this 1,000 times starting soon. In the next chapter, we talk a lot about this. This is the model for a linear equation. And what we know, because we all have an advantage. The 9th graders did this a lot with Mr. Manlove last year. Does any of you guys remember what M is? Uh-huh.
Okay, so y is your y-intercept.
What is M? Starts with an S.
Slope.
M is the slope of the line. And this is not a lesson on y equals mx plus b. Like we're going to do this in the next chapter. We'll talk to death about this. But what the 8th graders don't know is that when we write an equation in this particular format, the slope of the line will always be attached to x. Does anyone remember what b is?
B is the amount that you add after that.
Kind of. I mean, that's a great real world way to say it. But in the context of a graph, does anyone remember what b is? And again, I don't dislike your answer at all. It's specifically called the y-intercept. Good.
Yeah.
So if you remember this from last year, you guys saw equations like y equals 4x minus 2, y equals like negative 2/3 of x plus 5, stuff like this. Is this looking familiar? So we're going to do a few problems right now together where our goal is to make our equations look like this. I'm going to try to make this as short as I can so that you keep listening. The goal is to make our equations look like that, because if I can make an equation look like that, then I can show someone and prove and say, this is a linear equation because I made it look like the baseline linear model, y equals mx plus b. So let me give you a very simple example like this. In fact, I'll make it even easier. 5x plus y equals 10. Pause this real quick. Anyhow, could you make this look like y equals mx plus b?
Yeah.
What would you do?
I would take the y and put the 5x and with the y and put and equals with the addition sign, and it'd say y equals 5x plus 10.
Almost. You're on the right track. Let me ask you a different question. Can we get y by itself? Let me rephrase my question.
Yes.
Who has to go away if we're going to get y by itself?
5x.
The 5x does, right? The 10's not bothering anybody. So he's like, I'll just hang out here. But how do we kill a 5x?
Yeah.
Divide by 5x.
We subtract 5x like this.
So you divided 5x.
Nope. And we're left with our answer that says this: y equals negative 5x plus 10. The 10 is still a positive, right? But would you agree that this matches the model of y equals mx plus b?
Yeah.
Therefore, if someone gave me this purple equation and asked me if it's linear, I could say, well, look at this. Therefore, my answer is yes, it's linear. You follow? Okay, let's try another one. And the goal here, again, is to get y by itself. That's what I'm trying to tell you here. So say we had like 4xy minus 3 equals x.
You divide 4x?
Not yet. Let's add that 3 away first. We really should try to move away the extra bonus floaty terms always first. So I'm going to take this 3 and I'm going to add it across to both sides like this. So this is going to say 4xy
Equals 3x.
equals x plus 3. Can't put those together. And now to get the y officially by itself, what would I do? I would divide both sides by 4x like this. And so if I divide by 4x here and I divide both sides by 4x here, I'm left with my final answer, which says y equals x plus 3 over 4x. Does that match the y equals mx plus b model? It does not. Therefore, this is not a linear function. This is not a linear equation because I can't make it say y equals mx plus b. So that's one example of something that you're going to look for in problems like this is you're going to say, okay, by the way, every time you're going to get y by itself. That is what you will do. And then after that, you'll look at it and make a decision. And I think it's pretty obvious that this one doesn't look like that one, right? So that's not linear. Let's look at another example. How about if we had x squared minus y equals 4? How would we get y by itself on this one?
Well, you'd have to get,
Say it again. It's fine.
you'd have to get rid of x squared.
I don't disagree with that at all. Let's take the x squared and let's subtract it away. I think that's a great idea. So what's left on this left side over here?
Y equals or negative y equals.
Negative y equals negative x squared plus 4. Is y by itself?
No.
No. How are we going to get it by itself?
Plus y.
Nope. We're going to divide. We've seen this before where the variable we want to solve for has a stupid negative attached to it, and we know what to do. We just divide by -1 like this. Now, what's going to happen is we're going to have our final answer. We're going to say y equals positive x squared, and then the plus 4 changes to -4. Does this look like
No.
this? What makes us say no?
The subtraction symbol.
It's not the subtraction symbol.
It's the
It's
squared.
this. So what I'm going to tell you now, and this is a really half-hearted way, if you're still listening, I'm sorry if I've lost you. I think I overstayed my welcome in this lecture. What I want to tell you is this, that the two things you really need to look for an equation to not be linear are these. Number one, if you see any variables in the bottom of the fraction, like we did in this second example, remember how there was this x down here at the bottom? If you ever see that, if there's an occasion where that happens, it's not linear, guys. It's called rational. It's something completely else. And the other thing you want to look for is exponents. If you see any exponents or square roots or anything weird like that, it's not linear also. Okay, yeah, Cal.
So if you see the exponent, did you even have to write it out?
That's a great question. And I knew that question was coming in. I'm just going to say yes. And the only reason for this is I don't want there to be any gray area as to like, well, I kind of knew what was going to happen. So my rule is always with these, regardless of how obvious it is from the get-go, we're going to practice just getting y by itself. I don't disagree with you at all, for the record. Like once you know the rules, it's really easy to look at this one and say, yeah, it's not linear, but I still would like you guys to go through and formally get it to say y equals blah, 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 and then we'll make our decision officially at that point. It's a perfect, inevitable question at that point. So I don't know if that makes any sense at all, but when you get to the section on the test that says determine if each equation is linear or not, the goal is get y by itself, make a decision. Okay, so for the rest of the hour here, the couple things you may do. You may continue working on assignment 12 from yesterday, or you may get started on the practice assessment that I'm about to hand out. We good? And if you don't know how to do something, you'll just ask. All right, cool.